Now let's see the lost handling method. Deadlock handling method is deadlock detection and recovery. See, we have seen all the four. Now it is the fourth one. One handling method is deadlock avoidance. No, ignorance. Deadlock ignorance means the ostrich method. We'll act as if there is no deadlock at all. And the second method was deadlock prevention, which means we try to somehow avoid one of the necessary conditions, right? And the next one is deadlock avoidance, which is Banker's algorithm, right? And now we are going to see the last one, where we don't do any prevention or any avoidance, therefore deadlock is definitely going to occur. And what operating system will do is it will periodically keep checking the system for any presence of deadlock. In case if it detects any deadlock because of this at any time, then it is going to recover from the deadlock, right? So first challenge for the operating system in such a case is how is it going to detect the deadlock. So let's talk about the detection first. Now how are we going to detect the deadlock? So as you know that resources are of two types. One is resources can be of single instance type, other is resources can be of multi-instance type. So in single instance resource types, the deadlock can be detected by detecting the cycle, right? And you know how to detect a cycle in a graph, that we shall discuss it in the algorithms, right? So using a traversal method, we can find out that a cycle is present inside the deadlock order of E. So that is straightforward. Therefore, in case of single instance resource types, detecting a deadlock is straightforward. How can you detect it? By detecting the cycle, isn't it? Then if you see a cycle in single instance resource allocation graph, then there is a deadlock. That is how your operating system is going to detect a cycle in case of single instance resources, right? And the other one is multi-instance resource types. If each resource is going to have multiple instances, then in that case you are going to detect, you have to detect the this deadlock, but then cycle will not imply the deadlock, which means cycle is just a necessary condition. As cycle implies the deadlock, but then cycle is just a necessary condition but not the sufficient condition, right? So in this case what we do is we run that safety algorithm which we have seen already, right? So in case of this Banker's algorithm, we have already seen the safety algorithm, right? So we are going to run the same method here, right? So using safety algorithm, we can find out that there is a deadlock in case of multi-instance. So either you use this cycle method here or safety algorithm here, we can somehow detect the deadlock. Therefore your operating system can detect the deadlock. And after detecting the deadlock, what your operating system should do is it should take some measures so that this deadlock can be resolved somehow, right? That is called as recovery. Now let's talk about recovery methods. How can you recover from the deadlock is you can follow two approaches. One approach is you can do some actions on the resources, right? And then you can recover from the deadlock. One is preempt the resources. Preempt the resources means whatever resources you have been using, you pull one of the resource from its user, from the owner, and give it to the others in a hope that the other one will finish using this and eventually release it, and therefore again you can give it back. But then this method really requires manual intervention because you cannot write an algorithm to decide which resource has to be picked up, right? So manually we have to choose one of the resource and pull it out and then give it to the others. It is a headache, right? And the other one is roll back. So we will roll back to where some resources were not allocated. So right now you are going to see, for rolling back what we need is checkpointing. So while execution, we shall maintain various checkpoints, and then whenever there is a problem of deadlock, we shall go to the previous checkpoint or the system state where it was safe, right? See, let us say you are in state Sn, right? How did you reach there? You might have started from state S0 and from there S1, from there S2, so on here, right? And every state is going to be recorded, right? Every state is going to be recorded, right? And what we do is whenever there is a deadlock in some state, we roll back to some state where it was known that it was safe, right? And that is called as roll backing, right? When you roll back, then the resources will be released. Some resources will be released and then again will be in some state, and again we continue with the allocation of the resources, right? So anyway, you could either preempt one resource or two resources or n resources, or you could go back to a state where some of the resources will be completely released, where the system was safe. And now the other method is other method of recovery is, other than this resources, fine. Now let's deal with the process. So there are two ways to deal with the process. One way is kill a process, and other way is kill all processes, right? If you kill all processes and then again restart them, definitely that method will work, isn't it? Why? All the processes are going to be deleted and again they are going to be created. But then the problem is you might have to again do all the work, right? Some processes might have worked for hours together and now you kill them and again you restart it, and therefore they are going to run for even more hours, right? Therefore it is a waste of time. But instead of that, if you could kill one process at a time and then see if that process, if it is removed from the system, is going to resolve the deadlock, right? If you are lucky, you'll be able to kill only few processes and then resolve the system to the safety, right? But then selecting that one process is going to be a big deal. I mean, it is going to be difficult. Why? One thing is sometimes you have to choose one of the process which is present in the loop, so that if you remove it, then the loop will be broken. Or the other way is you have to select a process which is not in the loop but then holding a resource which is present inside the loop, right? And now how to choose a process? It is which has done least amount of work, or which is not very important. So there are various strategies that are being followed, right? Anyway, killing the process is one of the solution. Understood this? So this is a last resort, which means we will not do anything about prevention or avoidance, then definitely there will be deadlock, and therefore it is the responsibility of the operating system to detect it and then recover it. Okay, so that is how this method works. Fine.